All right, so we're going to turn our attention to circles this time around. We've been talking about area of quadrilaterals, polygons, things like that, and perimeter and whatnot. Now we're going to talk about circles. And the measures that we talk about with circles are circumference and area. And we're going to introduce arc length and the area of different sectors of a circle. Okay, there's definitely a difference between arc measure and arc length, and we'll make that distinction in just a second. Okay, so first and foremost, circumference and arc length, and the reason why these two guys are linked together. First of all, the circumference of a circle, of course, is just the distance around. If you were standing at a point on the circle, like right here, and you wanted to walk all the way around the circle, the circumference tells you how far that would be. Arc length, then, is if we were to cut an arc out of that circle, then the arc length would be the distance it would take for you to stand at one endpoint and walk to the other one. So it's a part of the circumference. Different than the arc measure. The arc measure we defined before as the same as the degree measure of the central angle that cuts it. There's a difference between the length of the arc and the measure of the arc, and it's a little weird, and I get that. That's just the way that it goes. Okay. So we want to talk about how to find the arc length. Okay. So circumference of a circle. Again, how do you find the circumference of a circle? Hopefully you remember from, I don't know, elementary school, where it's 2 pi r, 2 times the radius times pi. So we introduced the idea of pi here. Or if you want to think of it in terms of diameter, since 2 times the radius is the diameter, we can write this as pi times diameter, pi d. So either way. Okay? All right, so with circumference, we could just use the formula to find the circumference. Here we're going to take a quick look at an example where we can work backwards and find the radius. So circumference is 2 pi r. If the circumference of this circle is 26 meters, then we want to find the radius. And so we know the circumference. We're going to plug that in, 26 meters times 2 times pi, and we don't know what r is, and that's what we're solving for. So we're going to divide both sides by pi, or 2 pi actually. And so r is going to be equal to, and we could make this 13 over pi, but pi is an irrational number, and we don't like our denominators to be irrational. So we're not going to leave it like this. We're going to go ahead and divide this out. And so we're going to use 3.14 for pi, and that'll be accurate enough. So we divide 13 by pi. Okay, and we get 4.14 meters. Okay? So a use of circumference there. Now, circumference is the distance around a circle. So in the case of a tire, if you were to start the tire touching the ground here, and then roll it so that every piece of the tire touches the ground until you're all the way back to where you started, then that would give you how far the tire will travel if you roll it 1 revolution, if you turn it 1 time. Question here is, how far will this tire go if it makes 15 revolutions? Well, first off, let's find out how far it will go if it makes 1 revolution. And that's just the circumference. So again, circumference is 2 pi r, or this time we'll use pi d, just for fun. Right, so we're going to take pi and multiply it by the diameter. The diameter is represented by all of these measures added together. Which is going to be 11 plus 15, or 26 inches. And I want to take a quick second so that you understand the difference between an exact measure and an approximate measure. Because with pi, you have to round it because it's a decimal that goes on forever and never repeats. When you round a decimal, then you're approximating a result. You're not using every last piece of pi when you round it. And so if you want an exact answer, if you want an exact circumference, then you're going to just leave pi in, versus an approximate answer where you're going to round pi off and use that to find your measure. So if we do 26 times 3.14, then that would be an approximation. Okay, and that would be here 81.64 inches. Okay, we'll use the approximate for now, but just make sure you pay attention during any directions. If you want an exact measure, leave pi in. If it's okay to approximate it, then go ahead and multiply by 3.14. All right, so the circumference as an approximation here is 81.64 inches. We want to know how far the tire travels when it makes 15 revolutions. So I take this times 15. And so it's going to travel 1,224.6 inches. But it's asking for, to the nearest foot, how far the tire travels. So we actually need to convert this over to feet. And to do that, all we do is divide by 12. And to the nearest foot, this tire will travel about 102 feet after 15 revolutions. Okay, so a couple of things we needed to kind of keep track of there in that example. All right, now arc length and how it's related to circumference. Well, since arc length is a piece of the circumference, then we can write a ratio of arc length to circumference. And that's going to be equal to, since an arc is created by a central angle, and the central angle is part of the entire angle measure of a circle, then there are two ratios that we write, and we set them equal to each other. We write the ratio of lengths to the ratio of measures. And so it looks something like this. Okay, if we take the arc length, then it's going to be compared to the actual length of the circle around, which is circumference. That's going to be equal to the measure of the arc, the ratio of the measure of the arc compared to the measure of the entire circle, which is 360. So it's piece over whole circle, piece over whole circle. It's just the difference is left side talks about the length or distance, whereas the right side talks about measure, which is different. Okay, now you can certainly simplify this proportion to where it just gives you arc length, and that's what this has done down here. It's multiplied both sides by 2 pi r, and that's fine. You can do that, but I'm going to keep using the proportion because I never know what I'm going to have to find. If it's the measure of the arc length, the circumference of the circle, the radius, I'm going to leave this proportion, and I'm going to keep using this proportion, and then I'll cross multiply as I see fit. Okay? But anyway, just to acknowledge what's there on the slide, it's just taking that proportion and getting arc length by itself. Okay? All right, let's go use this. Find the length of each red arc. We want to find the length of this arc right here. Well, what we just saw is length compared to circumference, because they're the same type of measure, is equal to the measure compared to the entire degree measure of a circle. Well, arc length we don't know. That's going to be our x. The circumference is going to be 2 times pi times r. And that's going to be equal to the measure of the arc, which is 120 because the central angle is, compared to 360 degrees for the whole circle. we can do some simplifying here before we go find the arc length. This is going to be x over 22 pi equals 120 over 360 can reduce down to 1 to 3. And then we're just going to cross multiply. You get 3x equals 22 pi, divide by 3, and you get 22 pi over 3, which is the exact arc length. But if you want the approximate, then we're going to go ahead and multiply out 22 times 3.14, and then divide by 3, which gets us about 23.03 centimeters. Okay? So like I said, we're creating a proportion where we're comparing length to length and measure to measure. Part of circle to whole circle, part of circle to whole circle. Okay? Another one for you. We can use this to find the circumference. Again, I've got the arc length, the arc measure. I'm going to take the length of the arc and compare it to the circumference of the circle. And then I'm going to set that equal to comparing the measure of the arc to the entire degree measure of a circle. Now the arc length is 4.19 inches. It was given to us right here. The measure is 40 degrees because the central angle is. And we can reduce and solve. So 4.19 to C is going to be equal to 1 over 9. So you just take 4.19 times 9, and that will give you the circumference, which is 37.71 inches. Okay? So use the proportion there. I think that's a little bit easier. But you never know what you're going to have to find. Okay? Try finding the measure of the arc here. I'll give you a second, stop the video, see what you come up with, then start it back up and see if you're catching on to this idea of arc length. Okay, so you should have come up with this. Again, start with the proportion length over circumference equals measure over 360. The arc length is 44. The circumference is going to be 2 times pi times the radius, which is 15.28. That's going to be equal to the measure, which is x, the arc measure we don't know, compared to 360 degrees. And then it's just a matter of cross multiplying and solving for x, and you should get about 165 degrees. Okay? Hopefully, that's what you got. All right? All right. Quick application here. The curves at the ends of the track shown are 180-degree arcs of circles. They're half circles. The radius of the arc for a runner on the red path shown is 36.8 meters. About how far does this runner travel to go once around the track, round to the nearest tenth of a meter? Okay, well, to go once around the track, this guy's going to have to go 84.39 down this straightaway and 84.39 down the other straightaway. So far, his distance is the 84.39 plus the 84.39. We're going to have to add in these distances here and here, which are going to be the same. So if I find one, I find the other. So I need that arc length. Well, to find the arc length, again, we're going to use this proportion. Right? Length to circumference equals measure to 360. The length we don't know. The circumference is going to be 2 times pi times 36.8 is equal to, the measure is 180 degrees. It's a half circle over 360. Well, now we got to just do some arithmetic. Cross multiply, solve. You can reduce this guy down to 1 over 2. So you get 2x equals 3.6 pi. Divide by 2, and you end up back at 36.8 pi. If you multiply 36 times 8 times 3.14, you get 115.52. And there's two of those. That's over here as well. That's the length there and the length there. So I've got to add 115.52 twice to our distance. And when you do that, you do get 399.9 meters, or about 400 meters. Okay? This makes sense? Because the track is supposed to be about 400 meters around. All right? Okay, so that's arc length. Now I want to talk about sectors. And the good news is sectors are a lot like lengths as far as we're going to use a proportion or a comparison to find them. But before we can do that, we have to remind ourselves of the area of a circle, because the sector is basically a piece of the area. You find the area of a circle by pi r squared, known this for many, many years now. Okay? A couple of ways to use this. We can use it to help us find the diameter or the radius of something. This CD has an area of 113.1 square centimeters. We want to find the diameter. The formula is area equals pi r squared. So we plug in 113.1 here, pi, and then the radius we don't know. So usually this is r squared. So divide both sides by pi. So we get 113.1 divided by 3.14. And it's about 36.1 or so. And when we square root both sides and we round this, we're going to get about 6. So the radius is about 6 centimeters. If the radius is about 6 centimeters, then the diameter is 6 times 2, which is about 12 centimeters. Okay? All right. Now, the idea of a sector. A sector of a circle is the region bounded by two radii of the circle and their intercepted arc. Okay? In other words, the area of the circle is how much paper I would need to cover this entire circle. The area of a sector is how much paper I would need, or how much paint I would need to paint just this piece of the circle. So it's a part of the area of the circle. Okay? That's a sector, and this is a radius, that's a radius, this is the arc, and that's what the definition's talking about. Okay? Now, because it's a piece of the area, then just like the arc length, the arc sector can be compared to the area, and when we do that, it needs to be equal to comparing the measure of that arc to the whole circle 360 degrees. Again, I'm going to keep using this proportion. If you wanted to just find the area of sector, which is what this should say, area of a sector, then you could multiply both sides by pi r squared and just go use that. But because I never know exactly what we're going to need to find, I'm going to keep using the proportion. I think that'll be a little bit easier. Okay, so find the area of the small sector formed by angle UTV. All right. So in other words, how much paint will it take to paint all this? Well, area of sector compared to area of the circle is going to be equal to the measure of the arc compared to the whole measure of the circle, 360. Okay, we're trying to find the area of that sector. We know that r is 8, so this is going to be pi times 8 squared, and that's equal to the measure, which is 70, over the entire circle, which is 360. So this turns into x over 82 pi equals, and I'm going to reduce this to 7 over 36 just to make the math a little bit easier, but then we just cross multiply and solve. So 36x is equal to 574 pi, divide both sides by 36, and you get about 15.9 pi as an exact answer, or an approximate answer, which is this times 3.14, which is 50.07. And its area, so it is going to be in units squared. Okay? All right, use the diagram to find the area of the large sector. Now you try it. Stop the video, see if you can come up with it, and then start it back up and see if you're right. Okay, did you get 205.15 feet squared? Okay, again, we'll start with our proportions. Sector over the area of the circle equals the measure over the 360. We're looking for x. The radius is 14, so it's x over 14 squared pi equals 120 over 360. And then it's just a matter of cross-multiplying, solving. You can reduce a little bit to help the math get a little easier. Okay? All right, try this. You ordered a 12-inch pizza and cut the pizza into fourths to share with your 3 friends. How much pizza did each person eat? Well, basically, you're talking about a sector, right? So see if you can't figure that out. Stop the video, start it back up, and see if you're right. Okay, did you get 28.26 inches squared? Okay, using the area of a sector proportion, okay, sector over pi r squared equals measure over 360. We're trying to find x. And we're going to compare that to pi times 6 squared. This is the diameter, and we need the radius to plug into the area of a circle. And it says you cut it into fourths. So we're going to assume that the arc measure was 90 degrees. That's a fourth of 360. So x over 36 pi equals 1 over 4. Cross multiply and go solve. And that area of the sector is 28.26 inches squared. Now I know what you're thinking. Yes, theoretically, you could just find the area of the circle, which is going to be pi r squared, or pi times 6 squared, 36, and then divide that by 4 because you're cutting it into fourths. And then that would still give you 9 pi. So you can do it that way too. But I wanted to keep using the proportion so that we're familiar with it. Okay? All right. Here, we want to use this diagram to find the area of the circle, of that whole circle V. All right? And that's fine. It's not a big deal. We can keep using the proportion. Now, we can't just find the area of the circle because the area of the circle needs pi r squared. It needs the radius, and we don't know the radius. Okay? But we know the area of the sector. So we go sector over area of the circle equals measure over the 360. Area of a sector is 35. The measure of that arc is 40 degrees over 360. Reduce this down to 1 over 9, so 35 over area is equal to 1 over 9. Cross multiply in the area is just going to be 35 times 9, which is 315 meters squared. Okay? Piece of cake. And now you try. The area of quadrilateral RSTQ is 48 square feet. Find the area of circle Q. All right, so you know what? That's not parallelogram or quadrilateral RSTQ. That's supposed to be the sector. Okay? So we need to draw this. This is for circle Q, and we're going to draw the sector R, S, T, Q. So it's this sector right here. It's a little bit ambiguous. Okay, that area is 48 square feet. So that sector is 48 square feet. Find the area of the circle, just like the last example. So you know what? I'm just going to forget this all on overall. You can definitely work this out. You have a better picture in the example there. We're supposed to know that this angle is 120 degrees, and so you can just go use the proportion. Okay, I'm going to go ahead and move on. All right, example 5 here. Find the area of the figure, and we talked about before that if you want to find the area of a shape that you don't have a formula for, or don't remember the formula for, you can always break it up into parts that you do remember. Okay? Well, we've got basically a triangle and a half circle attached to it. So the total area is just going to be the area of that triangle plus the area of the half circle. Okay, so the area of the triangle is 1/2 base times height, and then we're going to add to it 1/2 pi r squared, because that's half that circle. 1/2 base times height for the triangle is just going to be 7 times 7. And then we got 1/2 times pi times the radius, which is 3.5 squared. Okay, not 7. The diameter is 7. So 7 times 7 is 49. Half of 49 is going to be 24.5. And then we've got 3.5 squared. And then divide that by 2, and you get 6.125 pi. Okay? Now, you can't combine those not like terms unless you go ahead and convert this area of the half circle there over to an approximation, 6.125 times 3.14, and that gets you about 43.7 square meters. Okay? One more area, there's a bonus here, one more area question for you, and then we'll wrap this up. Okay, find the area of the shaded region. Okay, well, the shaded region is just this rectangle with basically 3 circles cut out of it, right? There's 1, 2, and then this guy and this guy make 3. Okay, so let's find the area of the rectangle first, which is just going to be 18 times 6, which is going to be 108. Then we got to subtract out those circles. Now the good thing is those circles are all the same size because they're touching the top and the bottom of the rectangle. So their diameter is all going to be the same, which is 6, which means that the radius is 3. So the area of each circle is just pi times 3 squared, which is 9 pi. But there's 3 of them. So I'll multiply this by 3 to get 27 pi. And so now I want to subtract, for the area of the shaded region, 108 minus 27 pi, which is about 23.2 square feet. Okay? A lot of area work there, so hopefully that makes sense. Homework's out in Canvas. Make sure you have it done next time.